So today I'm going to talk to you a little bit about energy and what all that means. There are two types of energy. You have kinetic energy and potential energy. Kinetic energy is energy we have by our motion. If we're moving, we possess kinetic energy. Potential energy is by virtue of our position. So if I'm standing at the top of a cliff, or if I'm at the top of a roller coaster, we have high potential energy because there's potential for us to transfer that into kinetic energy. The formula to find the kinetic energy can be taken by doing half times mass times the velocity squared. Kinetic energy deals only with our mass and our speed. Potential energy has a few different things, because there are a few different ways in which we can affect our potential energy. Potential energy, G, this G stands for gravitational pull. So this is the gravitational potential energy, and we can find that by taking mass times gravity times the height. And this is, for example, if I'm holding this marker right here, it possesses gravitational potential energy. There's nothing else that's really pulling it down or has that pull, but gravity. So that when I drop it, gravity converts it into kinetic energy. There's also what is called compression or elastic potential energy, and that's like if we have a spring or a coil or a slinky type deal and we compress it, and as if we're about to like launch something, a pinball in an arcade game. So now we're going to apply this into this math problem. Okay, so say we have a 10 kilogram ball, that's mass, that's rolling at 6 meters per second, that's velocity. How much is the kinetic energy? Well, we can take 10 and 6 and plug it right into the formula. The kinetic energy will equal half times the mass, which is 10, times the volume, which is 6, squared. So our total kinetic energy equals 6 squared is 36, times 10 is 360, divided by 2 is 180. And the SI unit for kinetic energy is called the joule. Or for energy in general, is joules. Now for the second question. What speed would a 4 kilogram ball have to be rolled at to achieve the same kinetic energy? Well, if it has a different mass, it's going to have to go faster to achieve the same amount of kinetic energy. So let's try this one out. So we know the kinetic energy has to be 180 joules. And then it's half times the mass, which we know is 4. But we're trying to solve this time for the velocity. So this is going to be v squared, which you can see with that. So let's get everything on this side using algebra. Okay, so this is going to be 2, so we'll divide 180 by 2. V squared equals 90. And then we take the square root of both sides. The velocity equals 3 square roots of 10 meters per second. And there you go. So if I had a 4 kilogram ball that was rolling at 3 square roots of 10 meters per second, it would have the same kinetic energy as a 10 kilogram ball rolling at 6 meters per second. Okay, so just for one more other example, let's say I have, and I was kind of showing this earlier, let's say I have a book, okay? By virtue of its position, by how high I'm holding it, it has potential energy. Potential energy and kinetic energy are always being transferred one to the other. Right now it has potential energy. As it falls, it gets kinetic energy. But once it lands, it converts back into potential energy. So, right here it has potential energy, and that's kinetic energy, and then now, by virtue of its position, it has potential energy yet again. So there's always a balancing act. But when you encompass everything together, it's always going to be balanced, and that's called the conservation of energy. That the energy I have before something happens and the energy that I have afterwards is always going to equal the same. Thanks for listening, and yeah, that's just a little bit about energy.